Hello, everyone. Welcome to our 7.3 video. And 7.3 is titled Power Functions and Functions Operations. So our essential question for today is, how do I compute function operations such as adding and compositions? So we're going to talk about a couple different ways in which we're going to talk about using multiple functions at the same time and what that looks like. So the first thing that we're going to talk about is our definition of operations on functions. Okay, so the first thing that we see here is, let me quick grab my highlighter here, is it says that with the operations on functions, it says let f and g be any two functions. A new function h can be defined by performing any of the four basic operations of addition, subtraction, multiplication, and division on f and g. So that means that I can take two different functions and I can either add them together, I can subtract them, I can multiply them, or I can divide them. Now the domain of h consists of the x values that are in the domains of both f and g. Okay, so the main thing here is that we cannot have a denominator equal to 0. And if we cross that, we'll talk about what that looks like. So first of all, it gives us this example. So it says f of x equals x minus 2. So I know that f of x is equal to x minus 2. And g of x is equal to x squared plus 1. So right now what it wants us to do to find h of x is we are going to take f of x and we are going to add it to g of x. So I know that I've got h of x, okay, and I don't know what h of x is right now. But I know that f of x here is x minus 2. So x minus 2 is going to take place of my f of x. So I'll have x minus 2. And then I'm going to add it to now my g of x, which happens to be x squared plus 1. So right now I've got x minus 2 plus x squared plus 1. Okay, I'm going to look to combine like terms here. And luckily I have a negative 2 and a 1. So negative 2 plus 1 is going to get me negative 1. And then I'm going to write this in standard form. So I want my highest exponent first. So I would have my x squared would go first. That's my highest exponent. It's positive. Then I have my x, which is also positive. Oops, sorry. Plus x. And then finally, negative 2 plus 1 would get me negative 1. So this would be my final answer here of h of x. So all I did was just add and subtract, or I just added my f of x and my g of x. But now we're going to talk about subtraction. Okay, so now with subtraction, it says find h of x, and that's equal to f of x minus g of x. Okay, so same thing here. I've got h of x equal to, now my f of x happens to be x minus 2. So I'm going to take x minus 2. Okay, and I'm going to subtract it from my g of x. But I need to subtract it from everything in my g of x term. So my g of x I'm going to put in parentheses because it's subtracted from that whole thing. So now I've got x minus 2 minus x squared plus 1. So now this negative here is kind of like our distributive property. So we need to change all of these so we can kind of what we call keep change, or you can talk about chop slash, add the opposite. There's quite a few ways to define that there. So if a lot of people think about either add the opposite, keep change like I said, or chop slash. Either way, what that means is now these negatives are going to come inside of here. So now, again, I'm going to look to combine like terms. The only like terms that I have here happen to be my negative 2 and my negative 1. So when I write this in terms of h of x, again, my highest exponent goes first. And in this case, it's my x squared, and that's negative. So I'm going to have negative x squared. My x then happens to be positive, so I'll have plus x. And then negative 2 minus 1 is negative 3. So my final answer here would be h of x equals negative x squared plus x minus 3. Very nice. Let's take a look at example 3. It says find h of x which is equal to f of x times g of x. So now I know that h of x in this case is f of x, which is x minus 2. So I'm going to have x minus 2, and then that's multiplied by my g of x, which is x squared plus 1. So in order to find this and simplify this further here, I would need to distribute. So I'll take x times x squared is x cubed. I'll take my x times 1, which is just 1x. Negative 2 times x squared is negative 2x. And negative 2 times 1 is negative 2. Last thing I want to do here is I want to put this, oh, sorry, it's negative 2x squared, sorry. Then again, I want to put this in like term or in standard form. So my highest exponent down to my lowest. So I would say h of x equals x cubed minus 2x squared plus 1x minus 2. And right there would be our final answer there. So x cubed minus 2x squared plus 1x minus 2. Let's take a look at our last one in this situation here. So it says find h of x if I take f of x divided by g of x. So again, I've got h of x here, and this is equal to my f of x, which is x minus 2. And then it's divided by my g of x, which is x squared plus 1. Okay, at this point, we don't know how to simplify this any further. And this might be something we'll get to a little bit later. But right now, there's nothing really that I can do here to try to simplify this any further. So right now, this would just be our final answer, because you'd have to take the x minus 2 and you'd have to divide that whole thing by that x squared plus 1. So right now, this is going to be our final answer for right now. All right, so right now we're going to move on and we're going to talk about power functions. So power functions are a function of the form y equals ax, a times x to the bth power, where a is a real number and b is a rational number. Okay, so this will look kind of similar here, but the only difference now is now we're using those fractional exponents. So right now here, let's take a look. So it says h of x is equal to f of x plus g of x. So again, same thing here. I'm just going to color code this. So I'm going to have my f of x and my g of x. So if my h of x here, and I plug in my f of x here, which is 3x to the 1/3 power, and then I'm going to add that to my g of x, which is 2x to the 1/3 power. Again, I'm going to look at this and say, can I combine this? Okay, and again, in this fractional exponent, the base needs to be the same and the exponent needs to be the same. So in this case, these both have x's and they're both raised to the 1/3 power. So I can combine these here. So I would say, okay, that h of x is equal to 3 plus 2 would be 5x to the 1/3 power. And this would be our final answer. If we wanted to change this to root form, we could, but right now this is going to be okay. Let's take a look at our next one. Same process here, except the only difference is it's subtraction. So I'm going to have h of x is equal to my f of x is 3x to the 1/3 power. And then it's going to be subtracted by 2x to the 1/3 power. All right. So right now, again, like terms. So I'm just going to subtract 3 minus 2. And they're like terms because they both have the x and the 1/3. So 3 minus 2 will give me 1x to the 1/3 power. And right now, this is going to be our final answer. All right. Let's move on to a couple different examples. So now my f of x and my g of x are a little bit different here. So now my f of x here is 4x to the 1/3 and my g of x is x to the 1/2 power. Okay. So right now it says h of x is equal to f of x times g of x. So I'm going to multiply these. So I'm going to have 4x to the 1/3 power times x to the 1/2 power. Okay, again, this is our product of powers here. So remember that if I have two bases, two of the same bases multiplied together, I can add my exponents here. But I'm going to multiply my coefficients first. So remember that I've imaginarily got this 1. So 4 times 1 is going to get me 4. So I'll have h of x equals 4. And then I'm going to have x to the 1/3 plus 1/2. However, I run into a little bit of a dilemma here, and I see that these are not like terms, or these do not have a common denominator. So what I need to do is I need to change these to have a common denominator. So I need to think about what 3 and 2 have in common. And in this case, that happens to be 6. So I'm going to multiply this by 2/2, and I'll multiply this one by 3/3. And again, that's really just the same thing as 1, so we're just rewriting this in a different way. So now I'd have h of x equals 4, and I would have x to the 2/6 power plus 3/6. So 2/6 plus 3/6, 2 plus 3 would end up getting me 5, and I keep my denominator. So my final answer here should be 4x to the 3 plus 2 is 5, the 5/6 power. So right now, this would be my answer. H of x equals 4x to the 5/6 power. Let's take a look at our last one here. Now we're dividing. So h of x here is going to be equal to my f of x, which we said was 4 to the 1/3, 4x to the 1/3. And then it'll be divided by my g of x, which is x to the 1/2. Okay, this one happens to be our quotient of powers because we're dividing. So that tells us that we can go ahead and we can subtract. So I'm going to take 4 divided by 1. I'm going to worry about my numbers out in front first. 4 divided by 1 is 4. So I'll have h of x equals, I'll still have that 4, and then I'll have x to the 1/3 minus 1/2. Okay, again, same thing, need a common denominator here. So very similar to what we did in the last problem. We're going to multiply this by 2/2 and multiply this by 3/3. So then I'll have for h of x, I would have 4, and I would have x to the 2/6 minus 3/6. So 2 minus 3 is going to get me a -1. Uh-oh. So I'm going to have h of x equals 4x to the -1/6 power. All right. So right now here, our big issue right now is I've got this 1/6 that's negative. Remember, if I have a negative exponent, I want to go ahead and I want to move it down to the denominator there. So I'm going to keep the 4 up on top. So when I write out my final answer here, I'm going to move my thing. I would have h of x is equal to 4 to the x to the 1/6 power. Or if I wanted to write this in root form, I could say 4 over the 6 root of x. And this right here would be my final answer for this problem. Okay, and we can talk about rationalizing the denominator, but right now we're going to be okay with what we got. All right, so right now we're going to quick hop on over to the last page here. Oops, there we go. And we're going to talk about compositions. Okay, so compositions are a little bit different. So instead of just kind of multiplying, adding or subtracting, compositions here is where we take one of them and we kind of plug it in for the other one. So let's take a look here at that definition. So a composition here of a function f with the function g could be h of x equals f of g of x. So it kind of gets plugged inside of that. So it says the domain of h is a set of all x values such that x is in the domain of g and g of x is in the domain of f. So the domain of the compositions is determined by the domain of the original function. Okay. And what's important here is that order matters. Okay. If you guys notice here that f of g of x is not the same as g of f of x because the g is on the inside here and the f is on the inside. So these two are not the same. Okay. And I'm going to talk about what this looks like. So it says find each h of x below. Okay, so what this means here. So let's go ahead and let's talk about this. So my f of x is going to be 2. Whoops. My f of x is going to be 2. And my g of x is going to be x squared minus 1. So when I look at this here, if I want to plug this in, okay, if it says f of g of x, what this means is this g of x is going to take place. This g of x is going to take place of the x value in my f of x. So what this means here is I am going to take my g of x and it is going to get substituted in for the x value of my f of x. So right now I would have h of x equals, I would have that 2, but now instead of putting x there, I'm going to substitute it with my g of x. So I'm going to have x squared minus 1. Right here, I see that there's a 2 outside, so I just need to use my distributive property. So I'll distribute there and distribute there. So I'll be left with h of x equals 2 times x squared is 2x squared, and 2 times negative 1 is negative 2. So right here, my final answer would be 2x squared minus 2. Now let's look at this the other way. Now, it says, okay, now h of x is equal to g of f of x. So now my f of x is on the inside here. So that means that my f of x is now going to take place of my, let me just get my pen up here. My f of x is now going to take the place of the x value in my g of x. So anywhere there's an x in my g of x, it'll be replaced with that 2x or the f of x. So now I'm going to have 2x and that'll be squared minus 1. So now I need to take 2 squared, and 2 squared is going to get me 4. And x squared will just get me x squared. And then I'll have this minus 1 on the backside. All right, last problem for today. It says h of x equals f of x. So now my f of x here, let's just write this out again. So now my f of x is going to take place of my x value in the f of x. So this is a lot just like substitution here. So I'm still going to have my h of x. And it'll be equal to, I've got that 2, but now my x is replaced with 2x. So 2 times 2x is just going to get me 4x. So our composition is really, you are just substituting that value in for any x value in the other one that you're substituting for. So the inside one here, you want to go ahead and you want to plug it in for any x value in the other one. So in this one, we have the g of x, or f of g of x. So g of x took place of any x value in my f of x. We'll get some more practice with this together. For our summary for today, it says I need to plug in each function and the necessary part and follow the operations needed. Remember that order does matter. Okay, we'll get some more time with this together. If you guys have any questions, feel free to let me know. Have a great day. We'll see you later. Bye.